Hello everyone, my name is Rohit Singhal and we were discussing about the hydrocarbons. In the previous class, I have discussed about few properties and synthetic procedures to synthesize alkenes. In this class, we will discuss about the chemical properties of that. So, let us start with it. I have already discussed in the previous class that the alkenes are electron rich species and they mostly give the addition reactions. So, let us start with that we have already discussed is addition of dihydrogen, that means hydrogenation reaction. We have discussed that addition of hydrogens on alkenes in presence of palladium or platinum or nickel is the catalyst, we can synthesize alkanes and the reaction is called hydrogenation reaction. I have also told in the previous class about how this naming to these reactions occur. Second, again is addition of halogens. Addition of halogens means halogenation reaction. Okay. Let us suppose we are adding any halogen, let us say I am adding Br2. Okay. What I am supposed to get? Okay. Addition of halogen means I am adding a halogen molecule means a Br2, Cl2, I2, I am adding such kind of thing. Let us start with the Br2. Normal condition alkene does not react with these bromine molecules. Okay. Normally, the normal conditions do not react, alkenes do not react, but in the presence of let us suppose any some CCl4, what happens is one bromine goes to one carbon of alkene, another bromine goes to. Okay. So, this happens and this is a trans addition. That is why I have shown Br one is above and another is down, because what happens on the alkene, whenever a halogen has been added in presence of CCl4, what happens is one bromine goes to one carbon, another to the another carbon of the C double bond C, but both are in the opposite direction, means one is going upward direction, then another will be to the downward direction. So, this is a trans addition of the halogens. Okay. This is also one of the test. What happens, this Br2 will say is a reddish orange in color. This Br2 is reddish orange, whereas this product is colorless. So, this reaction is a very good test, or we can say very good way to test the unsaturation molecule. Okay. So, it is one of the tests often performed in the laboratories, whether to check that whether to check there is unsaturation present in the molecule or not. If there will be some unsaturation in the molecule, what will happen? The reddish orange color of the bromine will disappear to the colorless. Okay. So, instantly we know that there is unsaturation or not. Okay. So, similarly we can also use chloride and this will also give similar thing. A chloride can be also added, but most often this reaction is done in presence of Br2, because Br2 has a color, a reddish orange color, and when it forms a product the color disappears. So, it is a very good test to check whether there is unsaturation in your molecule or not. So, this is a laboratory test used to we perform. Okay. So, let us start with let us take another property, again addition property. This time let us add the hydrogen halide, and what the addition of hydrogen halide will be called? Hydrogen is added, halide will is it means hydro is for hydrogen, halogenation, it's a hydrohalogenation reaction. Okay. So, what we are talking about? Let us take an example, a simple example of alkene. Okay. A product will be formed. So, what will be the product? A hydrogen will be there is a C double bond C. So, what happens that the one H will the H will go to the one carbon of the alkene or C double bond C, and the bromide or the halogen we are taking is will go to the other alkene carbon. So, what will happen that one carbon will take up the hydrogen and one carbon will take up the bromine, and this C double bond C will be converted into a C single bond C. Okay. This double bond will be will no longer be there. Okay. So, this is the reaction. Let us take another example. If you are saying CH3 CH double bond CH CH3, again we are adding HBr, what it will give? CH3 CH, there will be a one H and one Br. Okay. But if you carefully see these two examples I have written now, these two are symmetrical alkenes. What these are? Symmetrical alkenes. What I mean to say by this is that if I have to HBr, if I have to add this HBr, it does not matter whether this hydrogen go to this carbon or this carbon, the product will be same. That means, let us say if the hydrogen goes here and the bromine goes here, or if the bromine goes here or the hydrogen goes here, these two are the same molecules. But the question arises is, what if we do have this unsymmetrical alkenes? Then how we will decide that the hydrogen will go to the which carbon and bromine will go to the which carbon? Okay. So, that will be the ambiguity in the question. So, let us take the question is, what in the case of unsymmetrical alkenes. Okay. Let us take an example of unsymmetrical alkenes, then we will better understand that. Okay. So, there are two possibilities. One is, let us say the hydrogen goes to the center carbon, the hydrogen goes to this carbon and the bromine goes to this carbon. The another possibility is that bromine goes to the center carbon and this goes to the this carbon. Both of the molecules are different. This is known as 1 bromopropane, and this will be termed as okay. So, there are two possibilities. Though are the two isomers, as we will get the two isomers. Now, which isomer will be formed by using the HBr in the case of unsymmetrical alkenes, we will discuss about that. Okay. So, there is a rule for that a scientist has discovered, that is called Markonikov. Markonikov rule. This is a rule which states which product is to be formed in case of unsymmetrical alkenes on the addition of the hydrogen halides. So, what's happen is, okay. So, for that, however, let's I am talking, Markovnikov said that the this product will be the major product and this is the minor product. Now, how he said that and how we understand that, how this 2 bromopropane means bromine is attaching to the middle carbon is more stable. Why is it so? Because the reason lies in the mechanism of this reaction. What happens is, when HBr, when a hydrogen halide is added to the alkene, this double bond splits, and this double bond can split in two possible ways. One is this way, that the carbon anion forms, that is the carbon cation forms on the center carbon, and this carbon which will have the negative charge will take up this H plus and will form CH3. Whereas the other possibility is, okay, this is the first possibility, and the other possibility is, if this double bond breaks like this. So, what will happen in that case? The positive charge will go there and negative charge forms here, and this negative charge will take up the H plus instantaneously to form this CH2. Okay. So, these two different moieties are possible on the addition of HBr. So, this is one. So, the cations are formed. Okay. So, what's the key point in the reaction is, carbocation is formed, means a cation on carbon. Carbocation means cation on carbon. Okay. It is the intermediate, and which carbocation is more stable will derive which product is to be formed. Okay. So, if it say this is a secondary carbocation, means the cation on which carbon is present is attached to the two other carbons. So, it is a secondary carbocation, whereas the in the other case it is a primary carbocation. And you must know that the secondary carbocation is more stable than the primary carbocation, and secondary is also more, and this tertiary is the most stable among the this. And why is it so? This is because of the plus I effect. You have studied in the previous classes or the junior classes about what is plus I effect. This is the inductive effect I am talking about. What happens in the secondary carbocation is, this secondary carbocations, there are two methyl groups. There are two methyl groups that is giving electron density towards the carbocation, and what is happening in this case is only one carbon donating the electron density. So, secondary carbocation, the carbocation is getting more stabilized due to two methyl groups or two R groups present and giving a greater induction effect. So, that is why the secondary carbocation are more stable than the primary carbocation, and tertiary carbocation, if in case it is more stable than the secondary and primary carbocations. So, what happens is, this carbocation is more stable. If this carbocation is more stable, what happens is, the H plus has been used by the carbon anion to form CH3. Now, what will happen is, Br minus will attack on this on this carbocation, and it will lead to the CH3 CH3. Okay. So, that is how we can say that this 2-bromopropane is the product that is formed in the major quantity. Okay. Let us take another example. Okay. Whenever such hydrohalogenation reaction is given to you and you need to be asked about the product, just see where the carbocations can be formed. Okay. So, there are two possibilities again for formation of carbocation. This double bond splitting is there, ki how this double bond is going to split. So, one possibility is this, the carbocation forms on this carbon. Here will be CH, it will be. And the other possibility is the carbocation forms on that carbon, and this takes up the. Now what happens, we just have to see which carbocation is more stable. We know this is a tertiary carbocation, this the cation on this carbon, which the carbon on which has the cation attached to the 3 other carbons, whereas this is a secondary carbocation, and tertiary carbocation are more stable than the secondary carbocation, and which are more stable than the primary carbocation. The reason I have stated earlier also is the plus I effect. Here 3 groups, 3 alkyl groups are giving the electron density. Here it is only the 2 alkyl groups giving the electron density to the carbocation to stabilize it. Okay. So, tertiary carbocation is more stable, means the bromide will go over to this carbon. So, what will happen, what is the product, it will be CH3 CBr CH3 CH2 CH3, and what will be the nomenclature for this? 1 2 3 4 will be 2 bromo, starting with the alphabetical, 2 bromo, 2 methyl butane. Okay. That is how we have formed which carbocation is more stable, which will lead to the which product will be formed. Okay. These carbocations formed in the reaction is an intermediate. Okay. What an intermediate is? Intermediate is if a reaction is taking place and before the formation of the product, a moiety is formed which we can separate, and that species is called the intermediate. And in this case, the intermediate is the carbocation. And one thing you should know, that more stable the intermediate, more stable will be the intermediate, Okay. So, what I am saying that these carbocations are the intermediates, and one thing we can see is the intermediates, if the intermediate is more stable, it will lead to the major product formation. Okay. So, these intermediates define with the which way the reaction is going to be. In this case, the carbocations are forming, tertiary carbocations are more stable than the secondary carbocations, which are more stable than the primary carbocations, and this stability of the carbocations determines which way the reaction is going to be, and this gives us the formation of this 2 methyl butane or 2 bromopropane rather than 1 bromopropane. Okay. And this is the rule that has been stated by the Markonikov. So, this rule is known as the Markonikov's rule or Markonikov's addition. This is also called as the Markonikov's addition or Markonikov's rule, and he is the first one to tell that which way the reaction is going to be in case of unsymmetrical alkenes on the addition of the hydrogen halides. In the next class, we will discuss about the further properties of alkenes, and we will also discuss it. Okay, we got the major product as like this, the 2 bromopropane as the major product. What if we need to prepare 1 bromopropane as the major product in inside using the same alkene and addition of hydrogen bromide. Is there any procedure, is there any method that we can synthesize one bromopropane as a major product, that we will discuss in the next class. Thank you.